Hello all, welcome to Brilliant Coaching Classes. I am Nilima Patil. In this video, we are going to start the new chapter Algebraic Expressions and Identities. Already in the earlier standards, you have studied what algebraic expressions are. These are all algebraic expressions. Algebraic expressions are formed using variable and constant. There can be one variable, sometimes there are two variables also. Variables are alphabets, English alphabets, and these are the constants, the numbers. So x plus 3. Here these are the terms. X and 3 are the two terms. So this algebraic expression contains two terms. So here x is a variable and 3 is constant. See another algebraic expressions, 2y minus 5. So here 2y and minus 5 are the two terms. Y is a variable, 2 and 5 are constants. Next, 3x square. So here x is a variable and 3 is constant. Here only one term. Next, 4xy plus 7. So this algebraic expression contains two terms. Here x and y are two different variables. 4 and 7 are constants. So this is about algebraic expressions. Now try this. Give 5 examples of expressions containing one variable and 5 examples of expressions containing two variables. So here one variable algebraic expressions. First 5p plus 7. So here only one variable is there and that is p. So this is an algebraic expressions with one variable. Next 3x square minus 2x plus 11. So here the variable is x, which is one variable. Next is 6z cube minus 10. Fourth expression is 7y cube minus 2y square plus y plus 3. So here also there is only one variable and that is y. Fifth, 13q square. So here the variable is q. So this is also an algebraic expression with one variable. Now let us see the algebraic expressions with two variables. First, 7x minus 5y. See, in this expression x and y are these two variables. Therefore, this is an algebraic expression with two variables. Next, minus 2xy plus 3y square x minus 8. So here also x and y are the two variables. Third, 4pq minus 7p square q square. So here also two variables are there, that is p and q. Fourth, 13ab square. So here a and b are the two variables. And fifth, 9y square z minus 4yz square plus 5zy plus 7. So here also there are two variables, y and z. So these are all algebraic expressions with two variables. Next, let us see what are terms, factors and coefficients in an algebraic expression. See here I have written two algebraic expressions. First is 4x plus 5. Now here the terms, these are the two terms, 4x and 5 are the two terms. The terms are added and then the expression is formed. The algebraic expression is formed after adding the terms. So here the terms are 4x and 5. These are the two terms. Now what are factors? Now every term is a product of its factors. So here 4x is a product of 4 and x. So 4 and x are the factors of this term 4x. 4 multiplied by x will get 4x. Therefore the factors of this term are 4 and x. Now the next term of this expression is 5 and 5 has only one factor, that is 5. So this is the only one factor. Now What are coefficients? The numerical factor of the term. Now for this term the numerical factor is 4, and for this term the numerical factor is 5. So the coefficients are numerical factors. So here 4 and here 5. So for this term 4x, the coefficient is 4 because it is a numerical factor of this term, and for this term 5, the coefficient is also 5 because there is only one factor and that is 5. So this is also the coefficient. Next, see another expression, 7xy minus 5x. Now here there are two terms, 7xy and minus 5x. So when these two terms are added, this algebraic expression is formed. Now for this term 7xy, what are the factors? 7xy is a product of 7x and y. It means when we multiply these three, we will get 7xy. Therefore, these are the factors of this term. 7x and y are the factors of the term 7xy. Next, minus 5x. So here minus 5 and x are the factors of this term minus 5x. Now, what are the coefficients of these terms? Now, for this term, the numerical factor is 7. So, the coefficient is 7 for the term 7xy. And here in minus 5x, the numerical factor is minus 5. So, minus 5 is the coefficient for this term minus 5x. Let us see what are monomials, binomials, trinomials, polynomials. See, the algebraic expression containing only one term are called monomials. Example, 5x, this is monomial because only one term is there. Even minus 9, this is also monomial. 6p square, this is also monomial. Then 8xyz, this is also monomial. This is an algebraic expression with a single term, therefore this is monomial. Next, what are binomials? An algebraic expression that contains two terms called binomial. Example, 6a minus 5b. Here two terms are there, 6a and minus 5b. Therefore, this expression is a binomial. Next, 7x square y plus 8y square x. Now here these are the two terms, 7x square y and 8y square x. So this is a binomial. This expression is a binomial. Now, what are trinomials? An algebraic expression that contains three terms is called trinomial. Example, 8a square minus 7b plus 9. So here three terms are there, 8a square minus 7b plus 9. Therefore, this is a trinomial. We will take one more example for trinomial. 17x square plus 8y square minus 7xyz. So this is a trinomial. There are three terms, 17x square, 8y square and minus 7xyz. So there are three terms and therefore it is a trinomial. Now, what are polynomials? Polynomial is an algebraic expression which contains one or more than one terms. It means all these monomials, binomials, trinomials are polynomials. These are all polynomials. So Polynomials contain monomials, even it contains binomials and trinomials. So polynomials are the algebraic expressions which contain one or more than one terms. It can be 5 terms also, it can be 7 term, that is a polynomial. See the definition for polynomial. Polynomial, an expression containing one or more terms with non-zero coefficient with variable having non-negative integer as exponents is called polynomial. See here, 2x square minus 3y. So the terms 2x square and minus 3y have their coefficient non-zero. This is 2 and here it is minus 3. It means the coefficients are non-zero, and also with variables having non-negative integers as exponent. So x is a variable here and the exponent is 2, which is non-negative integer. This is not negative. Then in minus 3y, y is the variable and the exponent here is 1, which is also non-negative integer. Therefore, this is a polynomial. Next, 4l plus 5m. The two terms are 4l and 5m. The coefficients are 4 and 5, which are non-zero, and the variables having the exponent non-negative integer. Here 1, so the variables having non-negative integers as their exponent. So this is a polynomial. Minus 9. Now there is no variable, but if you want, you can write the variable as x or y, z, any alphabet you can use. I have taken here x, and here we can write x raised to 0 because x raised to 0 is 1 and minus 9 into 1 is minus 9 only. Therefore, here minus 9 is a non-zero coefficient, and if we take variable as x, the exponent is non-negative integer. Here it is 0, which is non-negative integer. So the exponent is non-negative integer, therefore this is also a polynomial. Next, 4z. This is also polynomial because the coefficient is non-zero and z is the variable which has the exponent non-negative integer. So this is also a polynomial. So which are not polynomials? If I give one example, 0x square. Now see here, 0x square, the coefficient is 0. We need non-zero coefficient, but here it is 0, therefore this is not a polynomial. Or if I write 2 for this, if we take 2x raised to minus 2 minus 3y square. Now see here, in this term, for this variable x, the exponent is negative integer and we need only non-negative integer as exponent. So this is negative integer and therefore this is not a polynomial. So remember all these things which are polynomials and which are not polynomials. So remember this definition also. Now try this. First, classify the following as monomials, binomials, trinomials. Trinomials. First, minus z plus 5. See here, there are two terms, minus z and 5. Therefore, this is a binomial. Next, x plus y plus z. You can see there are three terms, x and y and z. The three terms, therefore it is a trinomial. Next, y plus z plus 100. Again there are three terms, therefore this is a trinomial. Next, AB minus AC. There are two terms, AB and minus AC. Two terms, therefore this is a binomial. Last, it is 17. Single term, only one term is there. Therefore, this is a monomial. Next, construct A. 3 binomials with only x as a variable. We need binomial, it means only 2 terms will be there and with variable x. So 10x square minus 5x. There are 2 terms and therefore this is a binomial and with the variable x. Second, minus 10x plus 3x square. So this is also binomial with variable x. Third, 15x square minus 7. So this is a binomial with variable x. There are 2 terms, so it is a binomial. Now 3 binomials with x and y as variable. Again we need binomials only, so 2 terms will be there, but now here 2 different variables are also there. We'll use these 2 as variable. First, 7x square y plus 3xy square. So this is a binomial. 2 terms are there and here xy variables are also used. Next, second, 13xy plus 5x square we need binomial, so only 2 terms and that much is sufficient. So 13xy plus 5x square. Third, again a binomial with x and y as variable. 9x cube y square minus 7x square y. Now 2 terms are there, so this is a binomial with variable x and y. Next, C. 3 monomials with x and y as variable. See, first one, 17x square y cube. So this is a single term, therefore it is a monomial and x and y are the variables here. Second, minus 9x cube y raised to 4. So this is also monomial with variable x and y. Third, 5xy, again a monomial with x and y as variable. D. 2 polynomials with 4 or more terms. So first one I have written here with 4 terms, 7x square y cube plus 5xy square minus 3x square y square plus 10. So here there are 4 terms, 7x square y cube first term, 5xy square second term, minus 3x square y square third term, plus 10 is the fourth term. So this is a polynomial with 4 terms. Next one I have written here with 5 terms. So 17abc minus 8a square b square c square plus ab minus 3ab square c plus 9a square. So this is a polynomial with 5 terms. Next we will see what are like and unlike terms. See here I have written some terms, 7x, 14x, minus 13x square, 5x square, 7y, 7xy, minus 9y square, minus 9x square, minus 5xy. Now first see what are like terms. The terms with the same variable with same exponent are called like terms. So here the like terms are 7x, 14x and no, that's all. So 7x and 14x are like terms. These are like terms. So these two were like terms. Next, here x and x, both variables were same with the same exponent 1, 1. Now 13x square, 5x square and minus 9x square. These are like terms because they have the variable as x with the same exponent 2, 2. So x square, x square, x square is there in each of these 3 terms. So those are like terms. Minus 13x square, 5x square, minus 9x square are like terms. Next, 7y, and now there is no term with the variable only y. Here there is y variable, but it has exponent 2 and this has exponent 1. So the exponents are different though the variables are same. Therefore these are not like terms. You can say they are unlike terms. Next, 7xy and minus 5xy. If it is yx, even then these are like terms. If it is minus 5yx, it is xy and this is yx. Though the order is different for this variable, but both the variables are present here. Here x, here also we have x, here y, here also we have y. Therefore, these two terms are also like terms. 7xy and minus 5yx are also like terms because they have same variables with same exponent. X is there with 1, 1 as their exponent, y is there with 1 as the exponent. So these are also like terms. Then what are unlike terms? So like here 7y and minus 9y square are unlike terms. Even you can say 5x square and 14x are also unlike terms. Why they are unlike? Because here the variable is same, x, but see the exponents are different. Here 1 and here 2. The exponents are different. Therefore 14x and 5x square are also unlike terms. Now try this. Write two terms which are like. First, 7xy. We can write minus 9xy. Another term which is like to this is 15xy. So xy variable is there. Therefore these are like terms. Then 4mn square. We'll write 5mn square, and the second term which is like to this we can write minus 13n square m. Here we first wrote n square and then m. Even then these are like terms because m is here, n square is there. So these are like terms. Next, third, 2l. Here we can write minus 3l and 50l. So these are all like terms. So here we have completed the introduction of algebraic expressions. Thank you.